Hello and welcome. Today we're going to be reviewing questions 6 to 10 of the SAT practice test number 7, the math no calculator section. Be sure to check out the videos of SAT practice test 2 as well as the other videos of this practice test if you haven't already. And as always, make sure to like and subscribe if you found these videos informative or you think they're helpful. Let's get into it. Question number 6, it says, a company that makes wildlife videos purchases camera equipment for $32,400. The equipment depreciates in value at a constant rate for 12 years, after which it is considered to have no monetary value, basically $0. How much is the camera equipment worth 4 years after its purchase? Well, let's see what we can do with this. Well, if in 12 years it completely depreciates, then it loses that $32,400 in 12 years. And after 4 years, it's gone through a third of that time. So since we're depreciating at a constant rate, we'll depreciate at it. It'll lose a third of its value in a third of the time. So it'll lose 1/3 or $10,800 of its value in 4 years. So the amount left is 2/3 of $30,400, or $21,600, which is answer choice C. All right, let's go to number 7. We're given the expression x squared plus 6x plus 4, and we're asked which of the following is equivalent to the expression above. Now we can see that each one of these has a term that's squared. Essentially, we want to be completing the square. All right, to complete the square, we have to add 5, because x squared plus 6x plus 9 is x plus 3 squared, right? Remember how you do b over a, or b over 2a, and then you square that? That's how you would do it here. So you end up with x squared plus 6x plus 4 is x squared plus 6x plus 9 minus 5, which is x plus 3 squared minus 5. Answer choice B. That's how you complete the square. If you're unsure about that, I highly recommend you go back and look at that because it is very crucial in using the quadratic formula and in solving these kinds of equations in general, trying to find information about quadratics. All right. Question number 8. Told that Ken is working this summer as part of a crew on a farm. He's earned $8 per hour for the first 10 hours he worked this week, and because of his performance, he got a raise to $10 an hour for the rest of the week. He saves 90% of his earnings, and he wants to know the least number of hours he must work to save $270. Well, we're told that for the first part, he has $80, right? He has $8 an hour for the first 10 hours. That's $80. Now, we're told that he wants to save $270, and since he saves 90% of his earnings, we divide 270 by 0.9 to get $300 that he needs to earn, and that way he'll save $270. So he already has $80, so he only needs $220 more. And since he's working at $10 per hour after his raise, he needs 22 more hours, or answer choice C. Keep going. Question number 9. Told that Marisa needs to hire at least 10 staff members for an upcoming project. Staff members will be made up of junior directors, who have a salary of $640 a week, senior directors, who are at $880 a week. And the budget is $9,700 per week. That's the maximum. And you have to hire at least 3 junior directors and at least 1 senior director. And we're trying to find a system of inequalities to describe all of this. So let's start at the ground and build up, right? So we have to have at least 10 staff members. So between the junior and senior directors, which is x and y, so x plus y has to be greater than or equal to 10. And there has to be at least 3 junior directors, so x is greater than or equal to 3. There must be at least 1 senior director, so y has to be greater than or equal to 1. Now, we haven't even done the last inequality yet. It's going to be the hardest one, but we don't even need to do the last inequality, because we can take these 3 inequalities and find that the answer is B, because it's the only answer choice that fulfills all 3 of those inequalities. However, I still do recommend finding the last inequality just to check your answer, right? We know that junior directors are paid $640 and senior directors are paid $880, so the total money is 640x plus 880y, and this is going to be less than or equal to 9,700. Again, this matches up with answer choice B, and that's why answer choice B is correct. All right, move on to the last question of this set. Let's see. We're given that a, b, c, and d are constants. It's a cubic function, but we don't have to solve it, thankfully. We're told that the equation has roots, -1, -3, and 5. Or of which of the following is a factor of this cubic function? Well, you might not know this, but there is this thing called the factor theorem, right? I suggest you look up on that too. It's related to quadratics and is most used in quadratics, but you can also use it here. Essentially, the factor theorem states that if you plug in a certain number into a function, where the function equals, say, like ax squared plus bx squared plus cx plus d, if you plug in any x value into that function, whatever number you get is your remainder, right? Now that's the remainder theorem. Basically, you just plug in an x value, whatever you get is your remainder. The factor theorem is a special case of the remainder theorem. It occurs when the remainder is 0, because if the remainder is 0, then it's divisible. So if you plug in that number, it's divisible, it's a factor. The factor theorem states that if you plug in a number and it becomes, if you plug in an x value, right, and that makes this whole function 0, then x minus that number, then the factor of x minus that number is going to be a factor of the function. So we can use this by doing x minus -1, x minus -3, and x minus 5. This gives you x plus 1, x plus 3, and x minus 5. All three of these are going to be factors of this big function, because if you plug in something, let's say you have x plus 1, if you plug in -1, or if you plug in -3, or if you plug in 5, then these factors become 0 and the function becomes 0. They become the same thing, so that's why you can do that, and these are factors of the function. Now, we are asked for which one is an actual factor. We have x plus 1, we have x plus 3, and x minus 5. The only one that matches up with the answer choices is x plus 1, which is answer choice B. That's the end of this set. Be sure to tune in next time when we look at questions 11 to 15. Until then, see you next time.